Hey everyone, welcome back. Today's day two of my 30-day FAANG grind. I'm solving 6 to 10 LeetCode problems daily, where I'll be breaking each down on video and I'll be sharing them with you here. I'm Divya. I have interned at Massachusetts Institute of Technology, where my area of focus was on machine learning and statistics. Globally, I rank on top 0.2% on LeetCode, and I'm aiming to crack FAANG interviews like most of you here. Yesterday, we crushed some sliding window basics, and today we are diving into two-pointer techniques, which is absolutely critical for FAANG interviews. We will also mix in sliding window variations to keep flexing those pattern muscles as we go on. If you find this helpful, please drop a like, share with a friend who's grinding too, and hit that subscribe button so that we can all crack these interviews together. Let us go. So for today, the topic is two pointers, and our third problem for day two is LeetCode 15, which is three sum. The problem states that we have been given an array and we have to find three different elements such that when they sum up, they yield zero. Okay, so this is the constraint. The constraint is pretty adequate, and this is the description of the problem. Let us try to investigate this problem on our dashboard. But before we do that, I just want you to look at the previous problem that I have solved, which is 2sum2 input array is sorted. I just want you to take a look at how the pointer is moving here, which I have explained in the previous video. Okay, you can take a look at that, how this problem was solved, and then you can come back to threesome and we'll try to investigate it further. Because 167, this one is really helpful and it will help us to deal with this problem. Okay. So this is the dashboard. We have been given a nums array and we have to find three distinct elements such that when we sum three of them, it gives us zero. Now, for a moment, imagine that we have been given just two distinct elements. How would we deal with that? How do we deal in that situation? In that situation, if you take a look at this point, we will just have left and R pointer, and we will just move left and R pointer accordingly until and unless we achieve the solution for the two sum statement, right? But in this case, we have an additional component, which is a third element, right? So we can say that this third element, which is an additional component, it is weighing down on the remaining L and R. Okay, it is affecting this L and R, but intrinsically, the overall characteristic of this problem, it remains very much identical to the two sum part where we have been given a sorted array. The only difference is that we have an additional weight of the first sum that we have to carry and distribute across left and R pointer. What I mean by that, I will explain. Suppose we start over here at an arbitrary index, and this is our first element. Okay, this is our first element. Let me call it AI. Now, what is the objective for us? The objective for us is to find AJ and AK such that AI, AJ, AK, they sum up to zero. Okay. Now, in this case, AI is our first element. How can we find AJ and AK? We can find AJ and AK by temporarily discarding or forgetting about AI, and on this remaining part, applying the two sum property using the two pointer that we solved in 167, we can easily scan and find AJ and AK. We do that, and that will yield us our answer, which is like AI summation AI from, I don't know, like we can just mention this header IJK like this, or it will just sum to zero. Okay. So yeah. Yeah, so that is how this problem is solved. It is again very much identical to 167. Overall characteristic of this problem remains very, very identical. So I will just simply walk you through this code. But again, we can pay attention to this diagram once again. In this problem, we just have an alienated, an extra component that has been introduced. But the overall characteristic of Tushan for this problem, it remains pretty much identical. And in this part of the array, we just need to apply the to some property using the two pointer, and how we move the pointer depends on the magnitude of our value that we are trying to achieve. In this case, it is zero, right? So let us move to the code part of this and let us try to understand what is going on here. The first thing that we do is we sort the array. Now, what does this do? When we sort the array, it makes our path pretty much easy. Why? Because it asks us to traverse along this path of the two-sum, right? Where we had this sorted array and we just needed to move the left and the right pointer depending upon the magnitude of the value, right? So when we sort the array, pretty much the game is done here. The second thing that we need to do is we need to declare result array. This is something that we will return as the final output. If I scroll down, you can see that it is exactly the same thing that I'm returning. It will be a list of all those numbers that sums up to the given value. In this case, the value that we are demanding is 0. Okay, let me scroll down. Okay, so now what do we do here? We scan through the loop. The I is the iterator here, and we scan through the entire element of the nums. So easily it will take me order of n, the linear time complexity, because we're scanning every single element. The question also states that we need to avoid duplicate pairs. Now, how do we avoid duplicate pairs? First of all, let us look at the code here. It tells me if my index is greater than 0, which means, hey, if I'm looking at some other element which is not starting at present at the starting part of the array, and if element at that part, if it is equivalent to the element adjacent to it on the left, then we are pretty much similar. We are pretty much sure that if there is a possibility from that index to generate an answer, then there is a 100% definite chance that the answer was already generated by the previous adjacent element. Wow, that was complicated, right? So let me break it down for you. Assume that our answer in this case is 1 plus a plus b is equivalent to 0. We are starting from this part, right? How do we generate that solution? We went here, we captured A, we captured B, boom, 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 and boom, right? The first state was generated, right? Now, let us try to see what if this line did not exist? What if this condition did not exist? In that case, what would happen? We would have captured 1 again. We would have went ahead and captured A and B again. Now, this red border part, it would have created a separate conjunction of element, right? And it would have been pretty much identical to the first part, which is like a duplicate, right? So we need to avoid this thing. So that is what this condition it is making sure that we don't go through such a case where the adjacent element is similar. Because if the adjacent element is similar, and if we are able to generate from that specific index, then there's a pretty much 100% definite chance that there is a case of duplicate that will arise. Okay, so that this line, it prevents us from doing that. Okay, now once we check that, the next thing that we do is we declare two different pointers. The first pointer that we declare is the left pointer. The second pointer that we declare is the right pointer. How do we declare the left pointer? We declare the left pointer one ahead of the ith index, and the right pointer is at the last index of the array, right? Then we make a check. Now, as you can see, this part, right, part up to this, from here to the end, like, okay, this part, it is exactly, or it is like pretty much identical to 167. Okay, we are just trying to adjust and move our left and right pointer. How do we do that? It is pretty much identical if you have a knowledge of 167, or if you have solved that problem. Okay, but again, I will walk through this thing. We have left and right, and we need to make sure that they don't coincide and they remain within the bound of each other. Then we declare a value variable, which will contain the value of the nums left, nums right, and nums I. Our objective is to make sure where the value is 0, store all those triplets. But if the value is greater than 0, it means our component has a magnitude of higher proportion which is coming from the right pointer. So what do? We move the right pointer to the left. If value is less, it means our component is deficit. Our current value is deficit, right? So we need to fill that deficit. So we move left plus one. Why? Array is sorted, and I'm moving left plus one, one left move one to the right. So it fetches a magnitude, higher magnitude element, right? Sorry. And in the third case, if our value, if it is equivalent to 0, okay, so that is the case we're dealing over here. In that case, we store all those triplets in our result array, okay, and then we increase the left pointer by 1. Now, again, when we increase the left pointer by 1, what do we need to make sure? We again see, the thing is I'm starting from this part, right? And currently my left pointer is here and my right pointer is here. Now I have formed a triplet. Let us assume the triplet is this thing. This is one of the part, this is one of the part, and this is one of the part. Okay. Now we need to make sure that, hey, since we are still in this while loop, okay, we need to make sure that we can fetch and form as many triplets or pair as possible using L and R. If I am standing at this point, I need to make sure how many different possible pairs I can generate using to some property in that part. So that is what I'm doing over here. I increase the left pointer by one, but as I do that, left pointer comes over here. I need to make sure that, hey, since this element, it is pretty much common for every single pair that will be generated in this region, I need to make sure that duplicate, we don't consider the duplicate pairs and attach it with this common element. Okay, so that is what we are doing over here. We increase the left one by one, but as we do that, we make sure that, hey, there is no duplicate element pair that we are considering. Okay, and we do that by checking if nums of left, whether it is equivalent to nums of left minus one, and if that is the case, we increase left by one, and we keep on doing this over and over again. And once we are out of this loop, we will return the answer. Okay, again, once we are out of this while loop, we'll go back to for loop, and we will start over again by considering a different element as a starting point. And then for that, if we start from this part, the left pointer will be this, the right pointer will be this, and our objective will be to form or to generate all those possible, pairs in this region that are going to lead us to our solution. And we'll append all those things with this common element. But while we generate all those pairs, we need to make sure that we don't generate duplicate pairs, and that is getting done over here, right? So yeah, that was all there is about this problem. As far as time complexity for this problem is considered, it is little tricky. The first thing that we can see is it is scanning for order of n. So that goes over here. But within this, there we have another loop, right? So I'm considering it will run for some factor of n, okay? So I'm just denoting it by capital F. But again, that will all be added with order of n log n. Why so? Because we are sorting the array, correct? And the space complexity will just be the space that is occupied or taken by this result thing. Okay. And yeah, so that is all there is to this problem. Let me go back to the LeetCode dashboard and we'll try to submit the solution to this problem and we'll see how it goes. Okay, I'm on the LeetCode dashboard. Let me try to submit. I have already copied my solution, so I'll just paste it and just run it. Okay, it should not be taking this long. Anyway, I will just consider it to be done. I don't know, there is some internet connectivity, but that is not an issue here. So the exact crux of this problem remains pretty much identical to 167. How we solved this part, line number 3 to 9 over here is pretty much identical to line number 10 to 19 over here, with just a very, very minor shift in this approach that we are taking over here. I hope you understood this problem. It was very easy considering if you have solved 167. And yeah, let us move to the next problem for the day, which will be the code problem number 18. Let us go.